Let's take a look at this question. Question 7.1. Determine f prime x from first principles if f of x is equal to minus 2x squared minus 1. So when we're doing first principles, remember we need to use the formula. But before we do that, let's work out f of x plus h and then f of x, and then we can substitute. So question 7.1, before we start, I want to work out what f of x plus h is. So f of x plus h is going to be minus 2, and instead of x, I'm going to replace that with x plus h all squared, and then minus 1. Let's simplify. That's going to be minus 2 into x squared plus 2xh plus h squared minus 1. Now we can distribute the negative 2 into the bracket. We can distribute it and we can simplify. We're going to get minus 2x squared minus 4xh minus 2h squared minus 1. We can't simplify further, so that's our value for f of x plus h. Or that's our expression, if you will. Now let's write out f of x. So we have both of them. So f of x is minus 2x squared minus 1. Now we have two choices here. Option number 1, or choice number 1, is we go straight to our formula, and we know our formula is f of x plus h, well, the limit as h approaches 0 of f of x plus h minus f of x divided by h. Now the choice is we can either substitute this and this straight into the fraction and then simplify from there, or you can work out the numerator first and then substitute. I think the second option would be better in this case because it just makes the whole thing a bit more easier to follow. So let's just work out the numerator. So the numerator is f of x plus h minus f of x. Now we got the two expressions, so let's substitute them. So minus 2x squared minus 4xh minus 2h squared minus 1, then minus open bracket minus 2x squared minus 1. Let's simplify here. So minus 2x squared minus 4xh minus 2h squared minus 1 plus 2x squared plus 1. Now we can simplify. That plus 1 will cancel with that minus 1. That 2x squared will cancel with that minus 2x squared, leaving my numerator now as just minus 4xh minus 2h squared. So we can substitute that in our numerator. So it is the limit of minus 4xh minus 2h squared all over h. And remember, that's equal to f prime x. Okay? Now we can take out h as a factor. So is the limit as h approaches 0 of h into minus 4x minus 2h divided by h. We can cancel the 2's. Now we can continue. I'm going to continue here on the right. So it's going to be the limit as h approaches 0 of minus 4x minus 2h. Now at this point we can substitute h is 0 and we can drop the limit. So we'll say next that minus 4x minus 2 into 0, and that gives us an answer of minus 4x. And that's our final answer. So again, there are a few options. You can either substitute everything in the numerator and then simplify while the fraction is there, or work it out separately and then substitute. Completely up to you. Okay, let's move on to the next question. Question 7.2. Determine f prime x if it is given that f of x is equal to minus 2x to the power of 3 plus 3x squared. Okay, let's do that. So 7.2.1, they tell us that f of x is minus 2x to the power of 3 minus 2x to the power of 3 plus 2x squared plus 3x squared, sorry, 3x squared. So this is just using the rule, right? So f prime x is going to equal, you take this exponent and you multiply it by the coefficient and then you minus 1 from the exponent. Same thing applies here. You multiply it there and then minus 1 from that exponent. So 3 times negative 2 is negative 6, x to the power of 2, and then 2 times 3 is 6, so plus 6x, 2 minus 1 is 1, and that's our answer. Alright, 7.2.2 dy dx if y equals 2x plus 1 over square root 4x. So, excuse me, 7.2.2 y equals 2x plus 1 over square root 4x. So what we need to do here is we need to simplify. So we can simplify this by saying y equals 2x plus 1 over, and then the square root of 4 is 2, and then we can rewrite this square root of x as simply x to the power of half. Now remember, to differentiate, you can't differentiate if x is in the denominator, you need to move it up. So we can move this up to the numerator, and in doing so we're going to get 2x plus half x to the power minus a half. Now we can differentiate it, and when we differentiate this, we apply our same rule that we applied in the previous question. There's an imaginary 1 here, so you multiply it there, and after you multiply, you minus 1 from that exponent. Likewise, for the next term, this minus half is going to be multiplied there, and then you're going to minus 1 from that minus half. And if you do this, you're going to get dy dx is going to equal 2x to the power of 0, then minus a quarter x, and then minus a half minus 1 is minus 3 over 2. So minus 3 over 2. Now what can we do with this x to the power of 0? We know that anything to the power of 0 is 1, so it's just going to be dy dx is going to equal 2 times 1 is 2, then minus a quarter x to the power minus 3 over 2. Okay, let's move on to the last question now. Last question says the graph of f prime x has a minimum turning point at 1 and minus 3. Determine the value of x for which f is concave down. Right? So what we can do here is we can sketch this. So we have a function, right? And the minimum turning point is 1 and negative 3. So let's say 1 and negative 3, somewhere there. So here's my function like this. Right? Now remember, when we're talking about concave up and concave down, we look at the second derivative. Right? Now, the second derivative, if the second derivative f double prime x is greater than 0, that means it's going to be concave up. If f double prime x is less than 0, that means it's going to be concave down. Now, since we don't have the actual function, we can't get the second derivative that easily. What we can do instead is we can look at the gradient, because we know that the gradient of the line is going to give us an indication of the second derivative. So if I have to draw a line here, this is a negative gradient, meaning that this is f double prime x is negative. However, if I draw a line this side, then this is a positive gradient, which means that f double prime x here is going to be positive. So we are looking for where it's going to be negative because we want concave down. So that means if we want a concave down value, x must be less than 1. Okay, that's it for this question. If you found it useful, leave a thumbs up, leave a like, share, subscribe. I'll see you in the next one. Bye-bye.